Good evening, ladies and gentlemen, and welcome to the ASTB resistor problem. This is part of the ASTB, which is the Aviation Selection Test Battery for Navy, Marine, Coast Guard guys. This is a resistor problem that I was getting a lot of questions about. And what I've done is I've actually set up a basic ASTB electronics video separately from this to prepare you. So if you've already seen the video, you kind of understand what's going to happen, how to handle this. In this test question, if two resistors and a battery are arranged in each of the above circuits, which circuit arrangement has greater resistance? The one that has a greater resistance is the series circuit, not the parallel. So if you looked at that video, you know the difference between a parallel and a series circuit, and if not, I encourage you to go look at it. So basically we have circuit A, and I'm just going to put A. You got circuit A and you have circuit B. Circuit A is the series circuit. Okay, so we have, let's see, resistor here. We have a resistor here. Alright, we have a battery here. Okay, so we have two resistors here. Boom, boom. This is the series circuit. And then on circuit B, we have a parallel circuit where we have our battery here. Okay. Making sure I get this right. We got our box formation here. And actually, take some of that out. And we're going to bring this down. And we're going to have a resistor here. And we're going to have a resistor here. Okay. So they want to know which circuit has the most resistance, and that would be circuit A. Okay. Again, if you looked at the video, you would know how we would come up with that. Now, in this question, they're not really giving you any numbers. They're not. They don't give you any numbers. They don't give you battery volt, the voltage of the battery. They don't even give you the resistors values. So what you got to do is you got to just kind of think and just be like, okay, which one of these? Okay, two resistors, same amount. So what I would do is I would assign this 10 ohms. Assign this 10 ohms. 10 ohms here and 10 ohms here. Because it's got to be balanced. They want to know two resistors and a battery arranged in the above circuits, which circuit has the greater resistance. Well, in order to see which arrangement has greater resistance, just come up with a number. Could have been 5, could have been 2, could have been 3, could have been whatever you wanted, but all of the circuits match. It could have been a 10 and a 5 as long as you got a 10 and a 5 here, or a 20 and a 30 and a 20 and a 30. And as a matter of fact, you know what? Come on, let's throw some salt in the game. Everyone's like, damn, leave us alone. R1, R2, this one, and this will be R1, and this will be R2. R2 will be 5. Okay, so total resistance, sorry about that, total resistance R1 plus R2. Alright, so R total equals R1, 10 ohms, plus R2, 5 ohms, 15 ohms of resistance. That's how strong it is. 15 ohms of resistance. 5 ohms will be weaker, 20 ohms will be stronger. Okay, so R total and the series circuit is R1 plus R2. If there were more, it'd be plus R3 plus R, big R, little 4, and dot, 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 dot. And the mathematical statement means we just keep going and going and going and going and going and going and going if we had that many resistors in the circuit. Now, you can come back and you can pause, write it down, do what you need to do, go to the other video. Now, in a parallel circuit series, did I get that in there? Parallel, I'll just put para. In the parallel circuit, when we want to find the resistance, it's actually 1 over total resistance. Okay, so we're going to work this out, and since there's 2 circuits, we don't need to do the regular blah 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 blah, which would be 1 over R1, 1 over, I'll do it, 1 over R1 plus 1 over R2 plus 1 over R3. I only use this for 3 or more circuits. When I only have resistors, I'm sorry, I keep saying circuits. When I have 3 or more resistors, when I have 2 resistors, what I do is I'll take R1 plus R2 over the product of R1, basically R1 times R2, and then come up with A over B, whatever that is, and then it's really like 1 over the resistance, and then so I'll just use the reciprocal and it works. But let's press on here. Alright, so R1 is 10 ohms, R2 is 5 ohms over R1, 10 ohms times 5 ohms, which equals 15 over 50. Now what I would do is I would reduce the fraction. So I could divide top and bottom by 5. 15 over 50, divide the numerator by 5, to reduce it, and we would get 3 over 10. Okay, and then what I would do is, just because this is really just 1 over, and so to get the number I need, just take the reciprocal, and I don't even do all that because I understand what needs to happen mathematically. Boop, just flip it around, 10 over 3. This is just like a division problem. It's 10 divided by 3, 3, 9, 1, 3. All right, so we'll just stop right there. One significant digit past the decimal. We'll just say 3.3, because basically another 0 would have came down, and 10 and 3, 3, 3, and it's actually a repeating decimal. So don't even worry about that. 3.3 ohms is what we have in this side. 3.3 ohms. So is that weaker or stronger? It was actually, I forget what we came up. We came up with 15 ohms on this side. That was really easy because 1 plus this 1 plus that one is 15 ohms. So the parallel circuit is actually has has less resistance. Series gave us 15 ohms strong. Parallel weakened the system, or weakened the resistance. So I hope that was clear. If that was not clear enough, just, hey, look, shoot me a message. You got my email, you got the comment section. I go through the comments. But that is the answer. So circuit A has the greater resistance, B is the wrong answer, circuit B was that choice, and then C, they have the same resistance. Clearly they don't, because ohms is equal to resistance. Showing how are these resistors, how much are these resistors fighting me? The current is trying to get through, but the resistor's like, no, man, you know, because the wire is straight, you know, the current's like going, and then the resistor's like, what would you have to do if you had a road like this? You gotta slow down because there's a lot of turns. You don't want to run off the road. Here on a straightaway, the electrons could, or the current could real fast. But when you get here, resistance. Oh man, the same thing. If there was a bulb, what does a bulb have to do? And I gave you guys some, just the wire and a bulb. So the wire's coming in and it's running. And then when it gets inside the bulb, it's gonna skid off. So it's gotta slow down, if you will. So I know there's a corny little analogy with the current and driving when we get into resistors, But this resistor causes resistance or slows down the current. This bulb is also, the bulb also has resistance. So I hope that helped. Keno Thomas, thank you for watching the ASTB prep. And hey, study hard and kick butt on the test. And keep watching the videos. Please like and subscribe and spread the word. Thank you.